Let's start today with a new chapter, chapter 14, lesson 1, which is talking about trigonometric identities. In this lesson, we are going to verify the trigonometric identities. Now, as you remember in chapter 8, if we have a function or the expression like 8 over x squared minus 4, and this is here 8x. And when I told you now what is the domain of this expressions, or the domain of this expression, or we can say what is the, one second, or like what is the excluded value. You told me before that it is the domain will be all the real numbers except the denominators, or the zeros of the denominator. So it will be all the real numbers except 2 and negative 2. And if you have it like 2x minus 4 over x minus 2 times x plus 3, when you simplify it, you get it as 2 times x minus 2 over x minus 2 times x plus 3. And then after simplification, it will come like 2 over x plus 3. So if I give you this expression and I told you, please simplify it, you tell me this is the simplified one. But what is the domain here? When you write the domain of the validity, you will not look at the last expression that is simplified. You look at the original one and you will take the 0 of the denominator. So you will tell me that the real of the domain here will be all the real numbers between negative infinity to infinity except 2 and negative 3, which is the 0 of the denominator. That's what happened with the expressions. That will the same happen here with the trigonometric identities.
Teacher, can I just say it's x unequal 2 and negative 3?
This is, no, if you're on the domain, you'll tell me that it is all real numbers except 2 and negative 3. Okay, let us see just like any remainder. Now, let's start with the trigonometric identities. The trigonometric identities is one variable is an equation that is true for all the values of the variable in all expressions. Yani, I mean like the identities, it is true in any equation. What are these trigonometric identities? You remember that we have, you remember you talk, I think in grade 9, three basic trigonometric functions, which is sine, cosine, and tan. So these are the three main functions. Sine, we write it as sin, cosine as cos, and tangent as tan. These are the three basics. They are six. Up to now, you know three, which is sine, cosine, and tan. Now, before talking about the other three, let's talk about their graphs. Here for the sine, this is the first one here for the sine. Here, you know that the sine of 0 is 0. So, I mean like, let's graph them here.
Teacher, is this lesson 4?
No, miss, this is 14, lesson 1. Now, let's talk about the numbers here from 0 pi over 2 by 3 pi over 2 and 2 pi. Now, what is the sign of 0? It is 0. And the sign of pi over 2, it's 1. The sign of pi is 0. This is from the table that I gave you last week. The sign of 3 pi over 2, it's -1. And the sign of 2 pi, it's 0. When you connect now between the points, you will get this graph here. This graph, this is for sine of x. So if you see here, at sine of 0 is 0, sine of pi over 2 is 1, and sine of 2 pi is 0. And if you continue, it will repeat themselves. This is here the graph for the sinusoidal function, sine of x. Now, if I ask you now here, what is the domain? And as you know that the domain of any function is the x values. So what is the domain here?
All real numbers. All numbers.
Or real numbers.
For this shape here, for this graph here, what is the domain?
From 0 to 2 pi.
It's 0, pi over 2, and pi.
In the one cycle.
Now, just 1 second, please.
Yeah, the cycle is 2 pi.
Yes, if I want now from you, okay, let's say that it is from 0 to 2 pi, if I'm talking about one cycle, and the 0 and 2 pi is included, or are included. And the range here for the sign will be from -1 to 1. Look at here. The minimum value is -1, and the maximum value is 1. And as I told you before, the sign of any value of any angle must be between -1 and 1. That's why here, as you see in the graph, the range will be from -1 to 1. This is the range, and the domain here, you can say it's from 0 to -2 pi as a one cycle, or some of the books they write it as from negative pi over 2 to pi over 2. It will be correct or 2. This is طبعا
Teacher, the other books, what they write?
Sorry?
What about the other books? What they write?
The other books?
Yeah, you say that the other books write.
No.
Negative.
No. Just wait. Let's make the sign, the domain here as from negative pi over 2 up to pi over 2. This is our book. From negative pi over 2 to pi over 2. That's here. We have it as, let's repeat it here. In our book, they say that this
But isn't from
pi over 2.
Pi over 2.
This is pi over 2.
But isn't that only 1 pi? Like from negative pi over 2 to pi over 2
Yes.
is only 1 pi.
Yes.
But the sine function is 2 pi. Or, maybe I forgot.
Sorry, can you? Yes, it is the side. This is in lesson 13.1 that you talk about the cycle. The cycle is from this point up to this point. This is one cycle. So if you want to write the domain, you write from negative pi over 2 to pi over 2.
Wasn't this for the tan?
No, for the tan, you write it from negative pi over 2 to pi over 2, but without the closed parentheses. Now, just 1 second. Wait me, please, until I finish. Okay. Now, okay. So this is here from negative pi over 2, 0 pi over 2 pi, 3 pi over 2, and 2 pi. So negative pi over 2, the sign of negative pi over 2 will be negative 1. Sign of 0 is 0. Sign of pi over 2 is 1. Sign of pi is 0. Sign of negative 3 pi over 2 is 0. And if 2 pi is 0. So if you connect now between them here, you will find them like this. This is for the sign. Now, if you want to find the domain for this interval here, you will tell me that the domain will be from negative pi over 2 to pi over 2, and both of them are included, and the range will be from the minimum point, which is negative 1, up to the maximum point, which is 1, and they are included. This is for the sine and for the cosine, for this domain and for the range for the sine.
Teacher, can you repeat the domain? Like, why you didn't say till 2 pi?
Miss, here this is here for one cycle. Yeah, I mean, like, if you want to take the domain for the sine, memorize it, that it is from negative pi over 2 to pi over 2, because it's make one cycle. Or in other words,
Isn't from negative pi over 2 to pi over 2 only half of the cycle?
Mrs.Dima بصراحة I forget cycle. Let's remember.
Teacher,
This is
pi over 2 and
no, see, wait, the domain, I think, Susan, yes, this is a half of cycle. Yes, because it must be from 0 to 2 pi, to 2 pi is a one cycle. From 0 to pi will be half a cycle. From negative pi over 2 to pi over 2 will be half a cycle. So the domain here from the sine is from negative pi over 2 to pi over 2. In this case, the range will be from negative 1 to 1, because the sign of negative pi over 2
Yeah,
is
that's
1,
my question.
and the sign
Like,
of pi over 2
why
is
is it only half a cycle?
yeah, the cycle, you have to write it from 0 to pi. This is for lesson 1 in chapter 13. If I told you where's the cycle, but they find that if I want to find or to write the domain for or the range for the sign, okay, let's come back from the range. The range, it is from negative 1 to 1. The minimum point is negative 1 and the maximum point is 1. When the sign is negative 1, at 3 pi over 2 or at negative pi over 2. But if you write it now from 3 pi over 2, you need to continue up to this point here, which is 5 pi over 2. This is correct, but you want now to write the first interval. So the first interval will be from this point, which is its sign is 1, and the lowest point, which is its sign, is negative 1. So it will be from negative pi over 2 to pi over 2. This is now for the sign. So from here, I want you to memorize what is the graph of the sign, what is the domain, and what is the range. So here, this is, just 1 second, please.
So, teacher, this is as like a rule, the one that you
Yes.
draw it.
Yes.
Okay.
This is here the graph for the sign. As I told you, this is at 0. At pi over 2, it will be 1. At pi, it will be 0. At 3 pi over 2, it's negative 1. And at 2 pi, it will be 0. Now, and let's talk about the domain and range. For the sign, it's from negative pi over 2 up to pi over 2. And they are, you have an equal sign. That's mean the angle, it could be pi over 2. And the domain is from negative 1 to 1. This is for the sine. Now let's talk about the cosine. For the cosine here, as you see, at Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. So if you want now to take the domain as half a cycle, you will start from 0 up to 2 pi. So it starts from 0 up to pi. So the domain here will be from 0 to pi, and both of them are included. So the domain here is from 0 to pi, and 0 and pi are included. Now, what about the range? The range, you will look at the minimum and the maximum number. What is the minimum number here? It's -1. And the maximum number, it's also, it's 1. So the range will be from -1 up to 1. That's why I told you before, that's the sine and the cosine, the sine and the cosine of any angle must be between -1 and 1.
Teacher, where's the minimum? The minimum line. Where's the minimum line and maximum line here?
Is it here? Here. Just 1 second here. To find the range, you have to look at the y values. So where's the value? Let's look at here. You will find it's from -1 up to 1.
Okay.
Okay. Or you can say that the sign, as you know from the table, that the sign of 0 is 1 and the sign of -pi is -1. So let's now distinguish here between here we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, let's draw the sign. The sign of 0 is 0. The sign of pi over 2 is, what's the sign of pi over 2?
It's 1.
It's 1, bravo. Sign of pi?
0.
0. Sign of 3 pi over 2?
-1.
-1. And sign of 2 pi?
0.
Thank you, 0. So if you connect now between this one here, the pink one here, this is for sine. Now, let's make it for the cosine. The sine of 0, a cosine, sorry, of 0.
What?
It's 1.
Bravo.
It's 1.
Cosine of pi over 2.
0.
0. Cosine of pi.
-1.
Bravo.
-1.
Cosine of 3 pi over 2.
0.
And cosine of 2 pi.
1.
1. So if you connect now between these points, like this is for the cosine. So this is here how the sine and how the cosine will be. And as you see here, this is here like the points that where both of the two curves are connected, which is at pi over 4. That's the cosine and the sine for an angle, which are thus equal pi over 4. And here, which is for, let's call it a radian, please. Which is 180 plus 45. Which is 5 pi over 4. These are the points that their cosine and sine are equal. So I'll repeat. If both of them, their domains are from -1 to 1, but the sign, the range for the sign is from negative pi to pi from negative pi over 2 to pi over 2, and the domain for the cosine is from 0 to pi. Do you have any questions?
Can you write it?
They are written.
Oh, okay. Teacher, how they know that from the range we will start from -1 to 1, not
What's the meaning
1
of range?
to -1?
Amo, you have to start
It's
from
the
the
one.
small up to the big number, from the least up to largest.
Okay.
Okay, with the range is for the y values. Look at the y values here. It's from -1. Oh, the y values here are only -1 and 1. So
Yes,
range,
okay.
it's mean y values. Y values, it's mean from -1 up to 1. Now, let's talk about the tangent here. This is the graph for the tangent. They found that the tan of 0 is 0. The tan of pi over 4, which is here, is 1. And the tan of, oh, let's graph it here first. Let's have the angles now here as 0, pi over 2, pi, 3 pi over 2, and 2 pi. And here you have negative pi over 2. Now, what is the sign of pi over 2? Sorry, the tan of pi over 2. Do you remember? Tan.
Oh no, not the one. It's undefined.
Yeah, it's
Undefined. Bravo. So since the tan of pi over 2 is undefined, so it's mean here like you have an vertical asymptotes. And what about sign of negative pi over 2? It will be the same. It's undefined.
Undefined.
So that's mean from negative pi over 2. Oh, sorry, at point negative pi over 2 and at pi over 2, the tan is undefined. Okay. What about the tan of 0?
It's 0.
0. And
zero.
what about the tan of pi over 4?
1.
1. What about like as an example, tan of 60?
It's square root of 3.
Yeah.
So if you write here pi over 3, you will find it's square root of 3, or it is 1.5 or 1.7. So it's here. What about tan of angle, let's say as an example, 85, or let's write it as a radian, 85 and 180. Let's find here 17 pi over 36. How it will be? What is the tan of this angle? Just 1 second, please.
Teacher, what is
So
this?
first we are going to convert it to degree and then find the tan of it, right?
Yes. So this is here, which is 85. Now tan of 85 here, it's 11. So here just I give you examples for angles between 0 up to pi over 2, from 0 to 90. I took 85, its tan is 11. So after you have now more angles from negative pi over 2 to pi over 2, you'll find that the tan of the graph of the tan will be like this. And from pi over 2 to 3 pi over 2, it will, sorry, it will repeat themselves like and from 3 pi over 2 to up to 5 pi over 2, you will have their vertical asymptotes and it will draw connected with 2 pi like this. This is here the graph for the tan. Just you have to make out to plot an angles, find their tan, and you will graph the tangent function. Now, for them here, they found that this for the domain, sorry, for the tan, is from negative pi over 2 to pi over 2. It's like the sign. But the things that's different here, that both of negative pi over 2 and pi over 2 are not included. So you have to put this parenthesis here. In the sign, I told you that they have to be closed. Closed, that means they are included. But here for the tan, you can use any angle between negative pi over 2 to pi over 2, but don't use pi over 2 and negative pi over 2 because they are not undefined. And if you look at the range now, the range here, where's the range? Is it from 1 to 1 or from negative infinity to infinity?
Negative infinity to infinity.
Negative infinity to infinity.
Here, as you see, it didn't stop at 1. Here we have number 11. And if you find, as an example, tan of 89, tan of 89 is 57. And if you try angle tan of like 89.999, you will find that their tangent is 57,295 for the angle 89.999. They will increase to infinity up when you reach pi over 2. When you reach pi over 2, it will tell you that is undefined. So the domain here from negative pi over 2 to pi over 2, which is not included, or they are not included, and the range will be from negative pi to pi. So let's come back here now. This is here for the tan, this is for the sine, and this is for the cosine.
Teacher, we don't have these photos in our lesson.
This is in
14.
chapter 13. Bring them from chapter 13.
Chapter 13?
Yes, here I bring these graphs from chapter 13. Just try to summarize chapter 13 here.
Teacher, yeah, why you didn't take the rest of chapter 13?
Miss, I told you I have to take 2 lessons from 13 and the whole chapter of 14.
Okay. Yeah.
Okay. So this is now here the domain and the range for the 3 basics function, sine, cosine, and tan. For the sine, as I told you now, for the sine of x, its domain is from negative pi over 2 to pi over 2, and they are closed. In other words, you can write it as like theta is greater or greater than or equal negative pi over 2, less than or equal pi over 2. This is for the range, the domain, and the range here is from negative 1 to 1. Now for the cosine of x. For the cosine here, it is from 0 to pi, and they are closed because there's a cosine for 0 and there's a cosine for pi. And in other words, you can write it as theta is greater than 0, less than pi. And their range is from negative 1 to 1. And let's talk about the cosine, the tan of x here. The tan of x is from negative pi over 2 to pi over 2, but in this case here they are not included. So in other words, I write it as theta greater than pi over 2, less than negative pi over 2, and less than pi over 2. I don't put this equal signs here. As you see, there's no equal signs. That means they are not negative pi over 2 and pi over 2 are the vertical asymptotes that which they are not included. So from here, I want you now to memorize the domain and the range for the sine, cosine, and tan. Do you have any question?
No, thank you.
No, teacher, it's clear.
Now, I told you now we have 6 basic functions. The 6 basic functions are, the first 3, they are sine, cosine, and tan. Now today we are talk about the other 3 functions which are the reciprocal of the first ones. Like you know the sine. Now all of us know that we have a sine. Yellow. Now we have sine, we have cosine, and we have tan. This is the first 3. They're reciprocal. 1 over sine and 1 over cosine and 1 over tan. This is the reciprocal. You know what is the reciprocal? Now 1 over sine now, the reciprocal of sine, we called it cosecant. Cosecant. And the reciprocal of cosine is secant. And the reciprocal of tan, we call it cotan. Cosecant, secant, and cotan. How you memorize it? If the denominator has letter S, the reciprocal will be start with letter C. And if the denominator has a letter C, the reciprocal will be have letter S. You don't have the same letters for them. C and S, S and C. Tan and cotan, from their name, they are related to each other. But remember, 1 over sine is cosecant and 1 over cosine is secant. So these are here the other 3. So we have sine, cosine, tan, cosecant, secant, and cotan. These are the other 3. I am cosecant, which written as CSC, 1 over sine, secant as CES, which is 1 over cosine, and cotangent or cot as 1 over tan. These are the other 3 basic identities. Do you have any question?
No, it's
No,
clear.
teacher, no, thank you.
Now you
Teacher,
have,
can you go back?
the others, you can leave the meeting now. Okay, yes, Rose.
Okay, have a nice day, teacher.
Have a nice
Have a
day.
nice day.